Alrighty then. Today is October something, midway through October, 18th. Hankinson, is it 18th today? hmm And we're finishing up our unit on rational numbers by correcting section 2.2. And question number 1 was the first question we had to do, and it says Max said the square root of 6.4. He said the square root, this is Max, said the square root of 6.4 is equal to 3.2. Linda, you don't see many Lindas anymore. That's kind of a name that's kind of gone by the wayside. The square root of 6.4 is equal to 0.8. And finally, Jamila, again, not a very common name. Jamila estimated the square root of 6.4, estimated. So estimated means it's an approximation, so we'll use that approximately equal to 2.5. Who is equal and why? Well, first of all, Max is a banana head because he thinks, like, if by his logic, I think he would think the square root of 100 was 50, and he'd probably think the square root of 9 was 4.5, I'm sure, right? Because all Max is doing is he is disassociating, or he is confusing square root with simply calculating half, and that's not what square root means, right? Square root means what number multiplied by itself gives you 6.4. 3.2 times 3.2 is not 6.4 because we know it's not, because it has to be greater than what number? 3.2 times 3.2, we don't know really what the answer is, but we know it has to be greater than 9, right? Because 3 times 3 is 9. So there's no way that the square root of 6.4 is 3.2. It's not impossible. So Max is incorrect. Linda, on the other hand, was like, well, hold on. I know, because we've been practicing this, I know the square root of 64 is 8. And therefore, the square root of 6.4 must be equal to 0.8. And again, if we reverse it and say, well, 0.8 times 0.8, is it possible that that is 6.4? No, because we have something less than 1 times less than 1. And we know that something 1 times 1 is 1. So something less than 1 times something less than 1 can't be 6.4. So she was onto something, but again, Linda wasn't quite there. So Linda didn't do it right. So obviously, it has to be Jamila. And here's what Jamila did. Jamila actually thought about it like this. She said, well, the square root of 6.4 is not a perfect square, right? So she knew that the square root of 4 is a perfect square because its square root is 2. And then she knew the square root of 9 is 3. So therefore, if I use a red dot and try and put the square root of 6.4, it has to fit somewhere between the square root of 4 and the square root of 9. So the square root of 5, the square root of 6, the square root of 7, the square root of 8, the square root of 9. So the square root of 6 would be roughly there, which if, well, I'm going to put it a little bit over because she's like, whatever. And she's like, square root of 6.4 has to be right in the middle of 2 and 3, so 2.5 seems reasonable. And that's the correct answer. What's the next one we had to do? 5? 6? Oh, we had to do 2? Well, we'll just start at 6 now. No, we'll start at 7. It says estimate and calculate the number that has a given square root. So really, another way to word this question is the square root of what number is approximately equal to 3.1. For B, it would be the square root of what number is approximately equal to 12.5, right? So if we think of it this way instead, that's a better way to ask the question. And for A, the square root of what number is 3.1? Well, we do know that the square root of 9 is exactly 3. And we do know the square root of 16 is exactly 4. So 3.1 is probably the square root of 10. So we're going to say, for this one, and I'll just grab my eraser. Oh, well, I guess that worked. The square root of 10 is approximately 3.1. Now, how am I going to check my answer? I'm going to grab a calculator. I'm going to say, what is the square root of 10? And it's 3.16, which is close enough. The next one, square root of what number is 12.5? Well, the square root of 144 is 12. And the square root of 169 is 13. So therefore, what number is the square root of what number is 12.5 right in the middle? Probably, I don't know, 155 maybe. We'll say square root of 155. Does that seem right, roughly? Should be right between 144 and 169. Grab our calculator. Say, what is the square root of 155? And it says 12.44. I'm pretty close. Close enough. I'm confident with that. So grab our eraser. Square root of 155-ish is approximately equal to 12.5. For C, the square root of what number is equal to 0.62? Now we're getting into more complex ones. All right, this is a complex one because we have to know the following. The square root of 0.49 is 0.7. And I know that because if I grab a calculator and say what is 0.7 times 0.7 or 0.7 squared, it's 0.49. So therefore, reversing it, the square root of 0.49 is 0.7. And therefore, the square root of 0.64 would be 0.8. Okay? And then we're saying, well, oh, I got this wrong. Oopsie daisy. Look at that. I made a mistake. Let's try that again. Oopsie daisy. Let's try this again. The square root of 0.36 is 0.6. The square root of 0.49 is 0.7. Now we're on the right track. So the square root of what number, ignore everything I just said before that, is equal to 0.62? Well, we're probably going to put it right, I don't know, right there, maybe. 0.62, the square root of 0, what number is 0.62? I'm going to say 0. Maybe 4, maybe 0.39. What do you think? What do you think, Dawson? 0.39 or 0.4? Let's go with 0.4. Let's see. What is the square root of 0.4? Square root button. The answer is 0.63. Was I close? Yeah, close enough. So probably 0.69 or 0. Oh, sorry. My brain's not working so well. Not enough coffee. 0.4. So the square root of 0.4 is approximately equal to 0.62 in my estimation. And finally, the last one, the square root of what number is equal to 0.29? So if I use my number line, the square root of, you can tell it's early on a Tuesday morning when I'm having difficulty with this. But the square root of 0.04 is 0.2, and the square root of 0.09 is 0.3. So the square root of what number is 0.29? It's going to be right over here. And if I'm going to estimate, since 0.04, 0.05, 0.06, 0.07, 0.08, and then 0.09 have to fit on that number line, right? We're going to guess the square root of, let's go 0.08. And if we grab our calculator and say, what is the square root of 0.08? The answer is 0.28, which is pretty close to 0.29. And therefore, that is our answer. The square root of 0.08 is approximately equal to 0.29. That was a very complex question, wasn't it? Question 8 says, estimate and calculate the area of each square given its side length. So obviously, the best thing you could probably do if this was a test question is first draw a picture and say, if the side length of that square is 4.3 centimeters, does anyone know what the formula is for the area of a square? Now, some people would say it's length times width or side times side. But in grade 9, the area of a square is actually side squared, or side times side squared. So what is 4.3 squared going to be equal to? Without drawing or grabbing a calculator, this is one of those number line questions again. So if I said 4 squared is 16 and 5 squared is 25, where would I put 4.3 squared? Well, I'd probably put it right there. And then using that number line to estimate between 16 and 25, I'm going to say the square root of maybe 19. So 4.3 squared is roughly 19. The square root of 19 is roughly 4.3 if I want to reverse it. And then I'm like, okay, well, let's check our answer. Let's see whether this is right. So what is the square root of 19? It's 4.35. So that's pretty good. Or what is 4.3 squared? If I reversed it, it's 18.49. So a really good guess if you used a calculator would be 18.5. But if without a calculator, just the number line, I'm going to estimate the area is probably approximately 19 square centimeters, just based on my number line. With B, We have a big massive field with 0.035 kilometers as its side length, 0.035 kilometers as its side length. Now this is tricky because most of you probably don't know. In fact, I'd say all of you don't know. Well, that if I drew a field with 0.04 kilometers, does anyone know what 0.04 squared is? Does anyone know? Anyone want to guess? 4 times 4 is 16, right? So what do you think it is? Isaiah, what do you think it is? What's 0.04 times 0.04? Using your brain, knowing that 16 has to exist in the product, what are you going to guess? Close. 0.0016 square kilometers would be that. So based on the fact that 0.035 is pretty close to 0.04, I'm going to make the assumption that this has to be a little bit less than that, but I'm going to say the area is going to be approximately equal to 0.0016 kilometers squared. Then I'm going to check my answer by actually taking my calculator and saying what is 0.035 times itself to figure out the area, or squaring it. And the answer is 0.001225. Was I close? I have no idea. That's the answer. So apparently we didn't have to do 8, but Taya told me a little late, but that's all right. It doesn't matter. Question 9 says, is each of the following rational numbers a perfect square? Explain. So another way to say that is the square root of 116 going to be a rational number or an irrational number? Meaning, is there a fraction that when multiplied by itself gets you 1/16? Another way to think of it is, what fraction multiplied by itself is 1 over 16? Is it possible to have a fraction? Yes or no? What's the numerator? 1. And what's the denominator? 4. So therefore, yes, it is. And to prove it, I could say the square root of 1/16 is equal to a quarter. Or a quarter times a quarter equals 1/16. For B, is the square root of 5/9 a perfect square? Or another way to think of it is there a fraction that when multiplied by itself is 5/9? Well, is there a denominator that will work? Yes, 3. But is there any number that multiplies by itself to give you 5? No. Some people will think 2.5 works, but 2.5 times 2.5 is not 5. 2.5 plus 2.5. So because there isn't, right up here. Because there isn't, we can say definitively that 5/9 is not a perfect square because there is no fraction that multiplies by itself to get you 5/9. The next one, C, 0.36. Is that a perfect square? Well, if we are using this without a calculator, it is best to examine these decimals as fractions. And since this is 36 hundredths, this is the same thing as saying this right here. Everyone agree with that? Since 0.36 is 36 hundredths, I could rework it as a fraction instead of a decimal, and then I could ask that same question. Is there a fraction that multiplies by itself to get you 36 hundredths? And is the answer yes or no? It is yes. My numerator is 6. My denominator is 10, so therefore it's a yes. And I could say the square root of 36 hundredths is 6/10. Or if I want to reduce it down to lowest terms, 3/5. Or if I want to keep it in decimal form, since 6/10 is written like this, I could also say the square root of 36 hundredths is 6/10. And finally, with 9/10, is the square root of 0.9 a perfect square? Your gut says yes, right? Right? Because you're thinking to yourself, 9 is a perfect square. So 0.9 is probably a perfect square. But when we then say, well, that's the same question as 9/10, right? And what fraction multiplied by itself is 9/10? Here we have the numerator working, just like conversely to the last one. But the denominator, there is no number that multiplies by itself to get you 10, so therefore 9/10 is not a perfect square. Question 11 says, for help with 11 and 12, refer to example 3 of, whatever. Okay, evaluate the square root of 324. So The square root of 324. Actually, the interesting thing is, I forgot to do this with you guys, and I should have done this with you. In grade 8, we learned this if you were in my class. So the first 10 perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. Right? Those are the first 10. The next 10 are 11 times 11, 121, 12 times 12, 144, 13 times 13, 169, 14 times 14, 196, 15 times 15, 225, 16 times 16, 256, 17 times 17 is 289, 18 times 18 is 324, and finally 19 times 19 is 361, and the last one, 20 times 20 is 400. These yellow highlighted ones from this point over, there is a significant chance you have never considered them. But back in elementary school, you probably learned 12 times 12, and you probably learned 11 times 11. But those yellow highlighted ones are new ones, right? So what is the square root of 324 based on that drawing I just did? Well, this is right here is 20 times 20, 19 times 19. It has to be 18 times 18, so therefore the square root of 324 is 18. For B, the square root of 2.89, well, if I look here on my new learning, 17 times 17 is 289, right? So what do we think the square root of 2.89 is if it is a perfect square? 1.7 times 1.7. It's either going to be 0.17 or 1.7, correct? Does it make sense that something less than 1 times something less than 1 will be 2? No. Does it make sense that something slightly more than 1 times something slightly more than 1 will be 2.89? Yes, it does. So we're just going to say, I think 1.7 times 1.7 is 2.89. I'm going to grab my calculator, 1.7, if we want to use a square button, or you can just do it times by itself, and you get 2.89, which is correct. So the square root there is 1.7. Looking at 0.0225, we know in our new learning that 13, 14, 15 times 15 is 225. So Andrew, what do we think the square root of 0.0225 will be if 15 times 15 equals 225? What do we think times itself is going to be 0.025? Any idea? 0.15 times 0.15. Does that make sense? He thinks that 0.15 times 0.15 is 0.0225. Grab the calculator. 0.15 times, instead of using the square button, I'm just going to get lazy and just do by itself. And it is 0.0225, so we're good. And finally, 2025. Well, this one's a little trickier because we don't know past. This is 20 times 20. Right? Does anyone know what 30 times 30 is? 900. Because 3 times 3 is 9, plus 2 zeros is 9. What's 40 times 40? 1600, right? 16 plus 2 zeros. What's 50 times 50? It is 2500. So based on this, if I was to make a number line and put the square root of 1600, it's 40, and the square root of 2500, it's 50, where would I put the square root of 2025? Would you say right in the middle, roughly? Right in the middle. So what would be a good guess if the square root of 2025 would roughly be there? Would you guess 45? Would that seem reasonable? So I'm going to guess it's 45, and then I'm going to say, okay, so what is 45 times 45? And the answer is 2025. Okay, that's how I could do it without a calculator. That's how you could do it without a calculator. Question number 12 says calculate the side length for each square. So this time you're given the area equals 169. So really what we're asking is what is the square root of 169? Because whatever that is, that's the side length, right? And what do we know based on our last table here? 169 is right here. So what times itself is 169? The answer is 13. So 13 times 13 gives you an area of 169. Hankinson, if I have an area of 0.16, I'm going to give you two choices. Since 16 is equal to 4 times 4, do you think the side length is 0.4 or 0.04? There's a good question. What times itself? Is 0.04 times 0.04 equal to 0.16? Or is 0.4 times 0.4 equal to 0.16? Is it A or B? Let's lock in our answers. Everybody that says A, raise your hand. Wow. Everyone that says B, raise your hand. All right, well, let's just check it out. The square root of 0.16, this is exciting, is 0.4. So therefore, the side length is 0.4, not 0.04. Do we have to do 13? Okay. So it says estimate each square root, then calculate it. So for A, the square root of 39 will fit on my number line between the square root of 36 and the square root of 49. Since the square root of 36 is that, and the square root of 49 is 7, I'm going to guess, I don't know, 6.3-ish. And then it says calculate it, so I have to actually take out my calculator and say, well, what is the square root of 39? Please be close, Will. 6.2. Oh, so close. So the estimation I gave was that the calculation was 6.2. Not bad. Not bad for an aging, middle-aged, 50-year-old, balding, out-of-shape math teacher. That sounds really bad to say it that way, but okay. It's on YouTube now. The square root of 4.5. Square root of 4 is 2. Square root of 9 is 3. The square root of 4.5. 4.5 is right around there, would you guess? 5 would be here, 6 would be here, 7 would be here, 8 would be here, 9 would be there. 4.5 roughly there. What's your guess? What's the square root of 4.5? Andrew, what do you think? Estimation. That little black dot right there. 2.2. All right. All right, 2.2. That's estimation by Andrew. Then I take my calculator and say, what is the square root of 4.5? Where's my calculator button? There it is. What is the square root of 4.5? The answer is 2.12. So 2.12 to 2 decimal places is our actual calculation. Andrew's estimation of 2.2 wasn't too bad, so we give him a star for that. Question C, square root of 0.87. This is trickier. This is much trickier. The square root of 0.81 is 0.9. And the square root of 1 is 1. So there's our number line set up. Where would the square root of 0.87 be? 82, 83, 84, 85, 86, 87, 89, 90, 91, 2, 3, 4, 5, 6, 7, 8, 9, 87, roughly there, maybe. I don't know. 0.9. No, I'm going to go 0.93. Grab a calculator. 0.87 square root. Oh my God, I'm so good. The estimation was that. The calculation was that. I get a shiny gold star for that one. And finally, the last one's too complicated, so we won't do it. And you know what? Let's just skip ahead all the way to the test question I'm going to give you. Where is the test question? What's the last one we were supposed to do? Oh, this is right here. Leon's, this is the test question I like. Leon's rectangular living room is 8 by 2 meters by 4.5 meters. A square rug covers 2/5 of the area of the floor. What is the side length of the rug to the nearest meter? So this is a great question. So the first thing I need to know is this square rug that we're going to put in here is going to cover 2/5 of the total area of that room. You with me? How are we going to figure out the total area of the room? What are we going to do first? So how do we do that? We're going to use the formula length times width. Correct, Taya? We're going to use 8.2, world's worst 8, times 4.5. Grab our calculator. 8.2 times 4.5 equals the area of the room. The area of the room is 36.9 meters. 36.9 meters. But the rug has to account for 2/5 of that. So there are two ways we can do this. We can think of 2/5 as being 0.4 or being 40%. If we think about 2/5 of the rug is going to be as a decimal 4, or as a percentage 40%, really what I want to do is I want to calculate what is 40% of 36.9, or alternatively, what is 2/5 of 36.9. So the best way to do it is this. 40% of 36.9 as a calculation will be 0.4 times 36.9, right? That's what the rug is going to account for. Grab my calculator. What is 40% of 36.9? The answer is 14.96. Is this 96 or 76? 76. So the area of this rug, which I'm now going to erase, the area is 14.76 square meters. Are we done yet? No, because it's not asking what is the area of the rug, it's asking for the side length. So now we have one more step to do. What is the square root of 14.76 without a calculator? What is the square root of 14.76 approximately based on our number line? So we know the square root of 9 is 3, and the square root of 16 is 4. 14.76, I don't think anyone would disagree. The square root of 14.76 is probably around there. Would you agree? What's a good guess before we grab the calculator? 3.8? 3.7? Not 3.9, that's a little bit too high, but 3.8, 3.7, something like that. That's my guess. Grab the calculator. What is the square root of that? Grab the square root button. It's 3.84. So therefore, the side length, the final answer, the side length of that rug is approximately 3.84 meters long.